For this assignment, we're going to learn one more method for graphing quadratics, and that is from a table. So we're going to really compile all of our skills thus far. So this assignment is a little bit different in Canvas because when you click on it, it's going to ask you to open this in a new tab. And when you click on opening it, you're going to see something like this, but up here in the right corner for students, you'll see a submit button. So I want to go through this example problem and then tell you what will be expected on the 3 problems for you to complete. So with this, I have a scrap piece of paper ready to go next to me, and I suggest that you do the same at home. And we are going to graph this function, f of x equals x squared minus 6x plus 5. So I have a scrap paper right here. I'm going to do it electronically so that you guys can follow along. And I know that I'm graphing it. So I'm going to use all the skills that I've learned so far and say, okay, well, what do I need to be able to graph this? There's lots of things that I can point out. This is in standard form. So one thing I know is that my Y-intercept is at 0, 5. And then I know that I have to have a vertex. That's a very, very important piece of information. Have to have the vertex. Now, there's a couple of ways that I can find it. I could see if this function factors. And if it does, I can use my axis of symmetry to find the vertex. Or if I don't want to factor, or maybe it doesn't factor, then I can use my axis of symmetry equation for x equals the opposite of b over 2a, calculate the axis of symmetry, and then plug it in to find the vertex. So lots of possibilities here. Let's go with the first one. Let's see if factoring works. So can I factor x squared minus 6x plus 5? And that answer is yeah, because 5 is prime. So I know I have 5 and 1. And for those to multiply to be positive 5 and add to be negative 6, this would be negative 5 and negative 1. Okay, so that tells me my x-intercepts are at 5 and 1. And if you wanted a visual for that, you could sketch a little xy axis like I have over here to the side. And I know that I have x-intercepts at 1 and 5. So what's the axis of symmetry? Well, that would be right in the middle of these, which would be x equals 3. Okay, so with that, I can now find my vertex. I know that the x has to be 3, and I'm going to plug that in to either the factored form or the standard form. It doesn't matter which one you plug it into, you'll get the same answer either way. I personally am going to put it into the factored form. And that would be 3 minus 5 over 3 minus 1. Subtract, I get negative 2. Subtract, I get positive 2. I get negative 4. So my vertex is at 3, negative 4. And I'm going to pause there for a minute. I don't have to put that on the graph here, okay? But what this does is I can now find values for a table. And that's the new piece for today, okay? We're going to work on getting more than just 3 points of a graph and drawing it. We're going to be looking at getting lots of points. So I'm going to erase my graph because we're going to go into, well, how to make a table. So here's the new information for today. When I create an XY table, I can choose, actually I need to scoot this guy over. I can choose any X values that I want, okay? Now, a key part of this is we know that the vertex happens in the middle of a parabola. So if I want to kind of make my table work a little easier, I want to place my vertex in the middle of my table. So I know my vertex is 3, -4. So I'm going to put it right here. 3 is the X value, -4 is the Y value, okay? So that's only one point in the table. And in today's activity, you're going to see that you have many other boxes to fill into the table. And here's how we do that. We're just going to fill in some X values that are both larger and smaller than 3. So if I go in order, if I go down, they get bigger. So I'm going to do X equals 3, X equals 4, X equals 5. And then if I go smaller, this would be 2 and 1. Okay, so then how do I find those Y values? Well, what we do, remember, f of X is the same thing as Y. So if I want to find that value, I just use my equation and I replace all the X's with the X value that I have in the table. So let's start with 1. If I plug this in, this would be 1 squared minus 6 times 1 plus 5. Okay, well, 1 squared is 1. 6 times 1 is 6, and plus 5. And I've really kind of run out of space, but 1 minus 6 is -5, plus 5 is 0. So I'm going to erase this just for I'm out of space. This would be the point 1, 0. And do the same thing with the 2. 2 squared is 4 minus 6 times 2 is 12, and then plus 5. If I go from left to right, 6 minus 12 is -8, plus 5 is -3. And that's the Y value. So I have the coordinate points 1, 0, 2, -3, 3, -4, because that was my vertex. That's kind of the one we've already solved for. And then now let's plug in 4. 4 squared is 16 minus 6 times 4 is 24, and then plus 5. 16 minus 24 is -8, plus 5 is -3. And plug in the 5. 5 squared is 25, minus 6 times 5 is 30, plus 5. So let's see. 25 minus 30 is -5, plus 5 is 0. Now, if you notice, we've had a pattern, and this should happen, right? We know that our vertex is in the middle of the parabola, and this is either our maximum point or our minimum point. So on each direction, these should repeat, right? 1 point away from the vertex, it's -3 and -3. 2 points away from the vertex, and it's a 0 and a 0. And that should always happen. Now, we never want to assume that it happens, because if I made a mistake calculating my vertex, now I'm in big trouble, because if I just assume that those repeat the way that they should, I'm not going to catch that error. So it is important to calculate each of those independently and just double check that, hey, I did get this pattern So we're good to go. Okay, so again, you would have all this on a scrap piece of paper next to you. And when you go into your assignment, you're going to fill out the table. So let me make this full screen so you guys see it a little better. So here's my table off to the left. See the box that says Vertex? I'm going to type in what my vertex was, which looking at my paper, that's 3, -4. Okay, and look, how cool is this? It's going to graph this for you. So this is really neat to do. So let's plug in the other points. We had 2, -3, and we had 1, 0, and I had 4, -3, and I had 5, 0. So look how neat this is. It graphs the parabola for you. Here's my x-axis. Here's my y-axis. Okay. So now let's go ahead and plug in. Let's finish out these boxes that we didn't get to. So if x is 0, plug in 0 to your equation. Well, 0 squared is 0 minus 6 times 0, still 0, plus 5. 0 minus 0 plus 5 is 5. Now, if I plug in our last box, so this would be a +6, what are we anticipating this y value to be? Well, we're anticipating it to be 5, right? And we can double check it by plugging it in. 6 squared is 36 minus 6 times 6, well, that's 36. 36 minus 36 is 0 plus 5. Once again, gives me 5. So now I've got a really good visual of this parabola, okay? All right, so now we're gonna fill in these things over here, and you can do them in any order. Let's start with the vertex, because we know that one. Now you have to list it as a coordinate point, so you have to have parentheses. You have to have a comma in between them. Okay, if you don't put those, you're not gonna receive full credit. You have to have parentheses or it's not a coordinate point. Okay, the y-intercept. Well, we talked about that at the beginning of the video, right? We can look at our graph, or we can look at our function and see that that's our c value. And again, write this as a coordinate point. So the x value would be 0, the y value would be 5. And again, the x value is 0 because we didn't go left or right any on this x-axis. We just went up. All right, X-intercepts. So we could factor this one, okay? Which if you look at your paper, we had that written down. Or we could look here and say, okay, well, this is in between 0 and 2, so this is a 1. And this is in between 4 and 6, so this was the 5. And we would like you to write those as coordinate points. So that is 1, 0, and 5, 0. Okay, those would be our x-intercepts. So now we get to domain and range. Hopefully by now you guys are feeling pretty comfortable with domain, that all parabolas have a domain of all real numbers, or from -infinity to +infinity, because this graph's going to go left forever and it's going to go right forever. So if you look here at the top right corner, there is an infinity symbol, and we're going to use that. So I am going to copy this, and there's a couple ways you can do it. You can click on it, right click your mouse, and you can do copy. Or if you want to do a shortcut, it's Control-C on your keyboard. It's the same thing as copy. Either way gets it there. Okay, so I need to type it in, comma, -infinity. To get the infinity symbol to paste, I can right click and do paste, and it shows up. Or the shortcut is Control-V as in Victor, Control-V. or you right-click and paste. Both of them will be fine. So from negative infinity to positive infinity. Okay, for the range here, now you've got to be careful and you have to look at your axis, right? Here's the y-axis. My vertex is at -4, but then it goes up. So to describe that, I would use the square bracket, which on your keyboard is the key just to the right of the letter P as in Paul. Square bracket -4, comma, infinity. And you're just going to paste that in again, or you could do right-click, paste, and then you're done. Okay, so for each of these, you're going to complete the table for the function. It's going to produce a graph for you, and then you're going to answer these 5 questions. Now, if your graph is not having a parabola show up, then you have an error in your table. Or if you don't get this repeating pattern, then you have an error in your table. So just go back and double check your math to see maybe you dropped a negative or maybe you didn't add correctly, anything like that. Okay, so after the example, you have 3 problems. So you have, here's your first one where it says function number 1. It's in like a pinkish color. Okay. Then you have function number 2, which is 4x squared minus 9. And you have function 3. Now, one thing I want to talk to you about function number 3 is this is a negative x squared. So in your head, right, you should already kind of have this thought of, hey, I know that parabola has to face down or open down because it's a negative parabola. But I want to go over one thing real quick when you're doing your tables. So let me exit out of this and go back to my scrap paper. If you have a negative x squared, so negative x squared, and I'm going to say, I don't know, plus 4x. We're just going to make up a random example. If I'm doing a table for this, if I have negative, oops, I don't want to do -3. Oops. 0, 1, and 2. When I plug values in, this negative in front of the x is like a -1. So I'm taking -1 times a -2 squared plus 4 times -2. And here is where your order of operations and taking care of your signs is going to be very important. I have to square that -2 before I can multiply it by a -1. So this is like a -1 times a +4, because -2 times -2 is a +4. And then if I want to do my multiplication of 4 times -2, that's -8. Okay, order of operations says I need to multiply this first. So I'm looking at -4 minus 8, which is -12. And it can be a lot to process. So really just work on, if you keep your work organized and don't do too much of it with mental math, then you should be fine. Not to say you can't do some of it with mental math. You totally can. So like when I'm evaluating -1, I'm going to think of this as such. And if you want to use a little bit of mental math, go ahead. -1 squared would be +1. But then I have to take it times this -1 out here, so it's going to turn negative again. And then I'm going to multiply 4 times -1, which is -4, which gets me -5. Okay? So nothing wrong with doing some mental math. Just be careful of trying to do too much at once. Okay, let's practice. Well, what if your x value was positive? Like, how would that look a little bit different? So I'm going to skip the 0, and I'm going to go to the 1. So this would be negative times 1 squared plus 4 times 1. So again, I have to square this before making it negative. If you want the 1 in front of there, you can. So this would be negative 1 times positive 1 plus 4. Do this multiplication, negative 1 plus 4, so this one is 3. Okay? And we'll do one more together just in case some of you guys are still feeling unsure about it. So if I plug in positive 2, and if you want to do a little bit of mental math, feel free. 2 squared is 4. Then times the negative is negative 4. 4 times 2 is 8, so we have negative 4 plus 8, which is 4. Okay? So when you have this negative out front, you need to be careful. Make sure you square your x value first, then multiply it by a negative. Now, we did not get the pattern here, right? And that's just because this is a made-up example. So don't let that throw you off, okay? The whole purpose of this example was just to go over if the x squared is negative. Okay, so don't worry that this doesn't have the pattern because I didn't find the vertex first like I should have for the assignment. Okay, so just one more time, you're going to go through all 3 of these problems here. And if you end up needing help, you can conference your teacher and we can go through and help you create these tables, help you find domain and range for any of these.